basically highlights of 2021. The major, I would say, achievements that the world or US has done was engineering feats. Unlike some of the other years where you have scientific discoveries, I think 2021 the highlights are just a fantastic engineering, and it starts off with Perseverance, which was launched actually in 2020, but then it landed in 2021 and has been operating on Mars for the past year and a half. And along with Perseverance, there's Ingenuity. Ingenuity was a helicopter that was made and assembled together with Perseverance. And the object was to test flight, aerodynamic flights on Mars. And Mars being, the atmosphere being, much thinner, and gravity being different, I guess is 1/6 of Earth. People really didn't know what to expect, although there were a lot of tests in preparing. First flight was in April and was successful. It was like a few seconds. It took off.
Or do you have any idea how one tests for difference in gravity?
I think it's 1/6.
No, I'm wondering how one can test that.
Well,
unless you sort of hold something, I don't know how you do it. Hold something up with a wire.
What JPL did or NASA did was to drop a helicopter. There was a large cylinder, and they dropped it, but not completely, to simulate 1/6 gravity. Okay, does that make sense? And then they thinned out the atmosphere. It was a vacuum, and they put in, the right amount of air, but gravity was simulated by dropping it, a bit. And they tested it, and it worked on Earth, but more remarkable, the first time they tested it on Mars, it worked. And in fact, the idea was really to test out this idea of flight on Mars maybe 2 or 3 times, and then kind of, drop it. But it's been so successful that they've had now 19 flights, and rather than just proof of principle, they're using it as a scouting mechanism for Perseverance. And so it is now part of the movement of Perseverance on Mars, that they use the helicopter to scout ahead, look for boulders or places where Perseverance would have trouble moving to, and then they create a path for it. So it's really working together, and so far they say it will work for years. The only limitation is dust on Mars and cold, but dust, because it's a helicopter, it kind of, by whirling the blades, you get rid of the dust. So it's a very good system.
So it's still active, George, and it's available for science.
Yeah, and it's the 19th flight that they just recorded a few minutes ago, or a couple of days ago, and it flew over 2 minutes and over 2 miles distance. So it's really now, being pushed to its limits. But right now,
Kind of amazing.
They don't know the limits yet. So, initially they said it was 30 seconds, but now they have it operating for at least 2 minutes. So that's Perseverance and Mars, which I think, is really a marvelous engineering feat. They're doing a lot of science, but that's in the initial stages still. The next major, I would say, achievement, American achievement together with Europe, is the James Webb Telescope. I mean, quite frankly, a lot of people didn't give it much of a chance to being successful in deployment. I mean, it's probably the most complicated piece of engineering that had to be assembled, had to be put together on a rocket, flown 1,000,000 miles away, and then opening up all of its apertures and diagrams. And I'll show you some of that later today. So the other thing that probably is worthwhile looking is the highlights of China. Our biggest competitor in space for a long time was Russia, but I think now China just quickly surpassed Russia and is competing directly with the US. They have a Mars mission and a rover that's moving around, and they also landed a probe on the moon, on the far side of the moon, and are moving around it. And in case any of you have been watching Space Force, which is a comedy on Netflix, it's the first season. They landed on the moon. Americans landed on the moon only to find the Chinese there. And then they were arguing about, who has rights to the moon. So it's a kind of a comedy, science fiction comedy, but worthwhile to look at. Okay, the next thing that I want to talk to briefly about is Parker Solar Probe. Now, this was launched in 2021, and its mission is to study the sun. But on the way to the sun, it kind of it kind of went by Venus, and it took some very exciting infrared images of the surface of Venus, and then compared it to what we know about Venus. And it adds another tool to study planets which have very heavy atmosphere, and you can't get, you can't see it with a telescope. But now with infrared, you can penetrate the atmosphere. And then, to kind of round off, there is Mars Curiosity, which is still bringing in data and beautiful pictures. And last but not least is Juno, which has been orbiting for the last number of years around Jupiter. And this year it has got close to some of the moons, and the pictures are beautiful. It's a video of you can imagine yourself sitting in a spaceship going around the Jupiter, and then watching the moon, Ganymede, come up on your surface. So anyway, that's whether we get through all of these, I don't know, but I will try. So as you can see, what I've done is I've downloaded a bunch of videos that you can see. Can you see that on the left side?
Yes.
Okay. And so what I done is I marked them 1, 2, 3, 4, 5, up to 8 if we get through, and I can just play.
Here we go. Bingo.
You got it. You have the sound.
Yeah, it's perfect.
Touchdown confirmed.
In the 10 months since the rover has landed, we've been busy, and it's been a year of perseverance. From operating during COVID to the challenges we experienced with sampling to interpreting the scientific results. It's such an appropriate name for the vehicle, but also for the team and the mission itself. This mission has a series of firsts that will help future generations understand more about our solar system. One of my favorite moments was seeing our first rock core sample. looking down the tube when it was still in the drill bit and confirming that it was indeed a success. Now that we've collected samples, everyone wants to know when and how they'll be coming back. We can't wait for the future mission to pick them up and ferry them to Earth to analyze if any of them show signs of ancient life.
The first flight of a powered aircraft to another planet.
Another highlight of this year was working with the helicopter team to deploy Ingenuity and experience the first powered flight on another planet. It was so amazing to see the team adapt to the environmental changes in order to keep flying. The helicopter has become a real asset and partner to our science team. It feels great to be part of making history. What motivates us as engineers and scientists exploring another planet is the opportunity to continuously learn more. Now that we've toured the floor of Jezero Crater, we look forward to investigating the Delta, a part of the crater where a river fed into a lake in the distant past. It's almost as if we're starting a new mission because we'll start to cover new ground and make new scientific discoveries. What I'm most proud of is the team, how we operate the rover, overcome challenges, and the dedication that everyone brings to their job each and every day.
All right.
Okay. So now to the next one. Are you still there, everybody?
We're all still here. We see the NASA logo.
Okay, now we're going to go to something else. And hopefully the same thing. This will record sounds on Mars. Can you hear that?
Yep, we're good.
On NASA's
All right,
Perseverance Mars rover, we have not one, but two microphones. And these microphones are the very first instruments of their kind ever to go to Mars. I'm Nina Lanza, and I'm a scientist at Los Alamos National Laboratory.
Hi, I'm Justin Mackey, an imaging scientist at NASA's Jet Propulsion Laboratory. One of the microphones is mounted on the mast and moves around as we point the cameras. The other microphone is mounted to the rover body, and it stays fixed onto the port side of the rover.
The two microphones that we sent were commercial off-the-shelf items. So these are things that you could just buy on the internet, and we put these on our rover.
It gives us a new dimension for which we can explore Mars and learn about the Martian environment.
First, we can just learn about the atmosphere by understanding how sound propagates through it. But we can also listen to the sounds of rover analyses on rocks and learn about rock material properties from that. And finally, we can also listen to the sounds the rover makes to understand better the state of health of our instruments.
There's a difference between Mars and Earth sounds. Sounds on Earth have very rich harmonics. You can hear multiple frequencies. It gives a really nice depth to the sound. On Mars, the atmosphere attenuates a lot of those higher frequencies, so you tend to hear the lower frequencies, and it's a much more isolated sound, a little more muted than the sounds we hear on Earth.
We've put together a list of some of the sounds we've recorded on Mars to date, so let's take a listen.
This is the sound of wind on Mars. For the first time, we can hear the wind blowing across the surface of Mars to go along with all of the images that we've acquired of dust devils and dust storms over the many years of exploration on the surface.
This is the sound of the rover driving on Mars. This sound might be a little bit weird because it doesn't sound like a regular driving sound, but that's because the rover's wheels are made of metal. So this metal is rolling over rocks and sand, and it makes this really clanky, squeaky sound.
Next, we have the SuperCam laser zapping rocks. We've taken a lot of pictures of rocks that have been zapped by the SuperCam, the little marks in the rocks, and for the first time we can hear these laser shots.
When it zaps a rock, it actually makes a sound. We can listen to that sound and learn something about the properties of the rock that we're analyzing. This is one of my absolute favorite sounds. This is the sound of a helicopter flying on Mars. We used this sound to actually understand the propagation of sound in general through the Martian atmosphere. And it turns out that we were totally wrong with our models. The Martian atmosphere can propagate sound a lot further than we thought it could. We've all seen these beautiful images that we get from Mars, but having sound to be able to add to those images, it makes me feel like I'm almost right there on the surface.
Now this has a little bit more about Ingenuity.
I'm surprised that those very low temperatures don't damage some of the moving parts.
Yeah, I don't know, quite frankly, what year or time of the year is on Mars right now where they're doing this. That's a little bit frustrating because I kind of like to know. I mean, their year lasts almost 24 months. So like April is 2 months. Every month is twice as long. So I don't know where they are right now, quite frankly. Okay, so that's about Perseverance. Any questions? Hello? Am I connected?
You are here.
Yeah, we're all muted.
Well, you're muting, okay.
George,
All right.
George, it was great. I think the videos just took what you said in words and just showed us what's going on. It's wonderful.
Okay, all right. Now, changing subjects, we're going to go to the Webb Telescope. And again, most of this is engineering achievements rather than operational. Operational, I think we'll start seeing some real images sometime, I think June, July. But right now it's getting things there, which is important. So let me okay, everybody see that? Steve?
Yes.
Okay, you
We
see
see
it? Okay, great. And the sound is coming in.
As the sun rises over the Guiana Space Center, the team conducts final checks on the health and status of the Ariane 5 rocket and its payload. The James Webb Space Telescope, NASA's #1 science priority. The Webb Telescope is designed to look back to a time when stars and galaxies were first forming, over 13.5 billion years ago. With its revolutionary design and capabilities, the Webb Telescope is about to unleash a new dawn of discovery.
À tous de vidéo, attention pour le décompte final. 10, 9, 8.
Seconds before liftoff, the Ariane 5's liquid-fueled engine comes to full power, followed by the ignition of the 2 solid rockets. We have liftoff. The Webb Telescope is finally on its way, the result of years of study and development by thousands of team members in the United States, Canada, and Europe. Webb's spacecraft ascends nearly vertically through the heavy lower atmosphere of Earth. As the rocket reaches maximum acceleration, the spent solid rocket motors are jettisoned safely into the Atlantic Ocean. Reaching the upper atmosphere where protection is no longer needed, the payload fairing is jettisoned and falls away. Accelerating through the atmosphere, the Ariane 5 rocket's first stage expends its fuel and shuts down.
Like an artichoke.
The empty first stage then separates from the upper stage. After first stage separation and before second stage ignition, the Webb Telescope has a slightly downward trajectory as it speeds over the Atlantic Ocean. The upper stage motor ignites and the ascent to L2 resumes, never again to be interrupted. The exposed telescope is delicate and must be protected from the sun's fierce heat. To avoid overheating and damage, a carefully designed series of oscillations are performed that provide the necessary protection. Near the end of powered flight, the roll program stops and the launcher then assumes the proper attitude for separation. After separation from the Ariane upper stage, the Webb Telescope continues its journey to L2 under its own power, taking the next step to its final orbital station 1 million miles from Earth. The Webb Telescope is about to unleash a new dawn of discovery. The Webb Telescope separates from the launcher's second stage. The white ring close to the Earth represents the Hubble Space Telescope's orbit, and the larger orbit is the geosynchronous orbit where most telecommunications satellites are located. The solar array is Webb's first deployment. When completed, all of Webb's electrical power needs are satisfied by the solar array for the remainder of the mission. The onboard control system continually monitors and updates the attitude to ensure power generation and thermal safety. To preserve the cleanliness of the mirrors, thrusters are located only on the sunlit side of the observatory. The trajectory is designed without employing a retrofire, which necessitates pointing the delicate telescope at the sun. If course corrections are needed, these velocity additions must be done early in the flight to most efficiently use the mission's limited precious fuel. After completing mid-course corrections, the Webb Telescope passes the orbit of the Moon. Webb's initial transformation is the deployment of the sunshield pallets. The tower separating the telescope and instruments from the spacecraft and sunshield is next. Next, the aft flap deploys. This is key to managing momentum buildup and fuel consumption. This structure helps to balance the pressure from the sun's light on the Webb telescope around its center of mass. After the sunshield pallets reach their final positions, the membrane launch restraints are released. These have kept the sunshield membrane safely in place from final stowage at the Northrop Grumman facility in California through shipment and launch. The sunshield protective covers roll back, permitting membrane deployment. The covers over the core region release next. Then the mid-booms extend and the sun shield assumes its hexagonal tennis court-sized shape. It is now time to tension the sunshield membranes, each thinner than a human hair, pulling each of the uniquely sized and shaped layers to their optimal position. When deployed, the sunshield allows the telescope to cool to 385 degrees Fahrenheit below zero, cold enough to liquefy air, while the layer closest to the sun is almost 190 degrees Fahrenheit above zero, nearly the boiling point of water. It's of almost 600 degrees. Truly fire and ice. Once in the shadow of the deployed sunshield, the telescope and instruments continue cooling down to their final operational cryogenic temperatures. At the completion of membrane tensioning, the secondary mirror deploys into position and is latched rigidly in place. The aft deployable radiator releases and springs into position, allowing the instruments to radiate their waste heat directly into space and away from the telescope. Disposing of excess heat is crucial to the mission so that it does not overwhelm the faint infrared signals to be collected from the cosmos. The cord-fold wings deploy and latch in place, completing the major deployments of the largest telescope in space. As the Webb Telescope continues out to its operational orbit around the Sun-Earth L2, the observatory continues to cool down to its final cryogenic temperature state. A trajectory correction applied 29 days after launch puts the Webb Telescope into its halo orbit, a key part of the mission design. The Sun-Earth L2 point is where Webb's orbit around the Sun is synchronized with Earth's. At this point, 1 million miles from Earth, Webb is free from the thermal influences of the Earth and all eclipses. Additionally, the Sun, Earth, and Moon, the brightest objects in the sky, are hidden by the deployed sunshield, giving Webb a dark, cold, and stable environment to carry out its mission of discovery. Once the mirrors and detectors are sufficiently cold, the wavefront sensing and control operations can begin. This sophisticated multi-step operation's ultimate goal is to position each of the Webb Telescope's movable mirrors into their correct final positions and orientations. Once the mirrors are aligned, the mission team will continue checking out the science instruments, preparing them for operations. Commissioning is completed about 160 days after launch, and the science mission is ready to begin. This brings to fruition the work of the thousands of members of the Webb team from the United States of America, Canada, and Europe. Astronomers from all over the world can now use this facility to study the universe. NASA's James Webb Space Telescope is a game changer. Discoveries made by this observatory will rewrite textbooks, inspiring the next generation of future engineers and scientists. This revolutionary tool will provide an unprecedented view into the birth of the first stars and galaxies, unleashing a new dawn of discovery.
Now they actually have started to align the 18 mirrors, so it looks like a single mirror. And I have here example what's happening.
First of all, the first evaluation images came in the middle of the night, but the team all came in and we gathered and we evaluated whether the camera was working well enough for us to proceed on with the alignment. And as we analyzed those first, photons, if you will, the team was pretty positive that the camera was working properly and the instrument was working properly. So we picked a star that was very bright and didn't have any stars near it that would contaminate the image. We know that the primary mirror segments aren't aligned, so they actually act like 18 separate telescopes, and we expect to see 18 separate images, one for each mirror, that are a little bit blurry at this point because we haven't aligned or focused anything. And so we pointed at a bright star and we made a mosaic. We actually took the near-infrared camera and we took images in different parts of the sky. And then we looked for the 18 spots from the 18 different telescopes, if you will. And we were very excited to find them. And the 18 spots were actually fairly close to each other. So really everything was very close to what was predicted. We've identified which of the 18 spots is which mirror. At this point, we even know which ones are from the wings. And it turns out one of the wings, you can actually see those 3 spots are a little farther over. And that's sort of what we expected. So we've identified all 18 spots, and the next step is to make an array of them. And then we're ready to start what we call global alignment, which is when each of those 18 spots will start to be aligned and focused. And that's sort of the last step before we take those 18 spots and put them on top of each other to start forming a single star going through the 18 separate telescopes. That's the work that will be starting soon. We also took a selfie of the primary mirror. We took an image of the primary mirror, and that helps us understand the alignment of the telescope, especially the primary mirror, to the camera itself and the instruments. There's actually a special lens in the near-infrared camera that you can put in, and it allows you to take a picture of the primary mirror itself. And in this particular case, one of the segments is pointing at a star, so that is the segment that lights up. But you can see the outline through the shadows of all 18 segments, and you also can see the outline of what's inside of the instrument itself, and we can see how well that primary mirror in the telescope is aligned to the instrument. And that gives us some initial confidence that the alignment looks good, and that's a good starting point for doing the alignment of the telescope. We have now gotten some data looking through focus, and we've been able to see that we don't see any surprises in the shapes of the mirrors that we're looking at. So far so good, but we do have a long way to go.
Okay, so the alignment continues, and by June we should have it all aligned and fixed first picture. But I think, it's still hard to believe that all of these mechanics, the servers, were as the thing was moving at incredible speed to get up to 1 million miles away from Earth, all of these things were happening. It was all pre-programmed. There was no human touch to kind of calibrate things or what have you. It's all done remotely. Okay, the next video is going to see some of the things that China has done.
Hey, George,
Yes,
on the James Webb, you said it was done remotely. So that means that it either has to be, you have to either measure time or distance to know when to do those things, correct?
correct.
Do you know how they did that? Whether it was just time, or were they able to take some measurements to determine distance, or neither of the two, or combination?
I think that they had a measure of distance, and then that triggered some things going. So in other words, depending upon where it was, how far, it triggered some action that had to be done. I mean, for example, the first solar panel was done fairly early because they wanted some extra power to be able to operate the telescope. But as you notice, they only opened up the first panel, and only the second one when it was almost there on the site, at L2 site. Now, you know, when I say L2 site, the thing is moving extremely fast relative to surroundings. I think one of the things that last week Charlie talked about, you know, L2, and I think the example of a merry-go-round. I mean, basically, you know, if you have a merry-go-round, and let's say the center pole is the sun, it shines on the father who's on the horse next to it, okay? And next to the father is one of his sons or daughters, and he wants to make sure that the son or daughter doesn't see the sun. So his shadow kind of covers the center pole. And as the merry-go-round goes round and round and round, the sun never sees the center pole. It's much more complicated, but basically it kind of tells you how the thing has to go around Earth, around sun in such a way that doesn't really see the sun.
So I saw a related thing about Webb, about how long it can stay up there and how much fuel it's needed. It's all hydrazine fuel for the positioning. I mean, some of that was to bring it up to the original position, but the design life is 5 years at least. If you go 10 and beyond. The good news is that I guess they didn't use a lot of fuel to get it in position, so its life is going to be longer. But to maintain the L2 orbit consistently over that time, it's going to burn the hydrazine.
They have to do some minor adjustments because L2 it's an unstable equilibrium. What that means is it can get easily float off, and so you need a little bit of push and tug, and that's where the fuels are going to be used. But as they said, because of the extremely successful launch, the amount of fuel that they have to do the adjustments is now, they say, 10 years at least, could be longer.
Do you know if they're going to have to reposition those 18 hexagonal reflectors depending on how far away the image that they want to take is from the James Webb?
As far as I know, this adjustment is done once, and once you get everything focused and you get, you know, a nice image in the center, you don't need to touch those again. It's like, you know, using your camera, and you can adjust it and you get focus. Then once the focus is done, you're okay. Now, it might be true that if you want to look at something close by, let's say Jupiter versus one of the galaxies that's billions of light years away, then there might have to be some readjustments.
Okay, so what's happening is they're assuming that everything is far enough away that they're not going to have to make those slight adjustments, or they perhaps can't make them.
Correct. And right now, the adjustments that you saw is done with a galaxy that's pretty far away.
Right.
So, okay, well, I think, I'm looking forward in June, July, August. So next year's update might have some terrific photos of galaxies that we haven't seen before.
George, am
Okay.
I correct in that they released a converged image within the last month?
Yes, they had one, a blurry image, yes.
Right.
I don't have that because it's just kind of a big blur. Well, let's turn to China.
Hello, it's Scott Manley here. It's been 3 months since China's Zhurong rover landed on Mars and began the process of slowly returning images and other scientific data from the surface of Mars. Now, depending upon how you measure it, China is the second country to successfully land on Mars, but some might argue it's third or the fourth. The other qualifiers are the Soviet Union, which landed Mars 3 before the United States did, but unfortunately Mars 3 never returned any data and broke down seconds after landing. And Britain actually landed Beagle 2, however, they lost contact with it immediately, and it was only years later that photographs from Mars Reconnaissance Orbiter showed that it had in fact began unfurling its solar panels, but had been unable to complete this in contact. So those are the other two candidates for soft landing, but let's be clear, this is vastly more successful, and I think they totally deserve the second place trophy here. Now, immediately after landing, there weren't any photos available, and it took them several days because the spacecraft, or the rover on the surface, had a direct uplink that had a bit rate of like 16 bits per second, and they weren't about to start uploading megabytes of images over that. They had to wait for the Tianwen spacecraft in orbit to shift into an orbit which would pass over the landing site like once every day. After a few days, we did get to see a few images. This is obviously from the top of the rover, showing the solar panels unfurled, the low-gain antenna there, and that circular feature there, that's a thermal ballast. It's like it contains a hydrocarbon in there, which has a freezing point roughly around the temperature of Mars. So it warms up during the day and cools down at night, but it tends to stay around that freezing point. And then there was this monochrome image supplied by one of the hazard avoidance cameras on the rover itself, looking down the ramp onto the surface of Mars. And they took about a week to descend onto the surface. And it wasn't just them, waiting for the data to come back. They got the data, they modeled the surface, and then they actually built a simulated version in the lab just to make sure that in the orientation that it would go down the rails just fine. Apparently the suspension system used by Zhurong has some extra active components, and they can raise the front and the rear of the rover independently if necessary. But yeah, this is a really cool little animation showing the descent onto the surface, and of course we get to see the lander that it came down on. And I think it's worth noting that we haven't had a lander that's been delivered to the surface of Mars like this, as in a rocket-powered platform with a ramp. If you look at Curiosity and Perseverance, they used the Sky Crane, and Opportunity and Spirit had this big sort of bouncy ball thing. This is a single rocket engine landing on the surface of Mars, and we'll talk a little more about that later. Now, around the same time, Tianwen-1 was able to return this image of the landing site. Now, Tianwen-1 is very much a science satellite in its own right, and as it's working as a relay, because it's had to set its orbit to synchronize with the rover, it's sort of limiting its science gathering capabilities. But anyway, on the left, this is before, on the right, this is after, and you see 3 locations marked on Mars. At the top, you have the lander showing an interesting burn pattern around it. There's 2 objects there because one is the lander, the other is the rover. Below that, they have the aeroshell and the parachute marked. And to the southwest of that, that is where the heat shield landed. Of course, NASA has its own imaging capabilities. It has the Mars Reconnaissance Orbiter with the high-rise camera, and that's able to get resolutions down to like 0.5 meter or less. In this image, you can very clearly see the lander and the rover as 2 separate entities, and depending upon how you process this, there's evidence of the ramps being visible on the right side of this image, facing mostly east. And yes, The burn scar is a very interesting shape, and I had a lot of questions about this. It shows us a generally dark area with two light areas heading to the north and the south. And this is sort of very similar in some ways to what we saw for Perseverance's landing, but that was via a sky crane. And its shape was due to having rockets that were firing over the top of the rover to the left and the right, and those formed two distinct burn marks. And then along the middle there was this stagnation zone where the air or the gases didn't flow quite as fast. But Zhurong's lander only had a single engine, and from this image there was nothing getting in the way of the flow. There were the four legs, but if the four legs were responsible for causing these two bright lobes, how did that work? Why didn't you see a cross-shaped pattern? So I think what this is a post-landing event. After they land, they've got high-pressure propellant tanks, and they just want to vent them, and the vents just happen to be located out of the sides. These are the sides that are 90 degrees away from the landing ramp, so that they're not going to get in the way of that. I think, that's what's going on here. Also, if you look at this image of the lander, this is sort of lined up with the roll reaction control thrusters, so those are sitting along the edge. And if you imagine when this is going down, there is an aeroshell over the top of that and a heat shield underneath, and that's where the jets poke out through the aeroshell so that they can control the descent. So it's conceivable that they just depressurize the system by firing those engines as well, and those are pointed at 90 degrees to that ramp and exactly along the line of those burn scars. Also, this image gives us an amazing view of the crater which was made underneath the lander due to the rocket exhaust from that main engine softly touching down on Mars. Now, this is a much deeper crater than we've seen on other planetary landers, but really it's the first time we've seen underneath a Mars lander which has landed on a rocket. For comparison, the Chang'e missions to the moon, they didn't leave a crater that was nearly so obvious, and that's because they shut their engine down about 15 feet above the surface and then fell to the surface. They didn't do that on Mars, they powered all the way to the surface. But also there's a strong effect whereby a rocket in a vacuum expands out very quickly, whereas a rocket in an atmosphere, even an atmosphere as thin as that of Mars, will be collimated and form into a jet that bores into the surface much more efficiently than it would on the moon. This is one of the things that leads to the sky crane, which when you think about it sounds a bit ridiculous, but when actually you look at the science, it's the best way to do it. There's another little engineering feature here. There's a little cylindrical object that sort of hangs out from underneath the lip there. That is like the black box that was there in case of an accident. They had a team build this, and you can get an idea of how big it is by this photo of the guy working on it on the train. They shot this out of a cannon to make sure it could survive any reasonable impact, and that was there. If there was a crash, it would be able to transmit some parts of the telemetry so that they could perhaps have a better chance next time. But yeah, they didn't need it. After a while, they did also start sharing engineering camera views. This is, of course, the parachute deployment, which NASA didn't really capture camera views of the parachute deployment until Perseverance. And yeah, I can see why these days cameras are so much cheaper, so it makes sense to capture this data and share it for improvements to future flights. This is the aeroshell getting popped off. You can see the parachute pulling it away. And of course, once this goes away, the vehicle starts to go into powered descent mode, uses its rocket propulsion. It has many sensors, it has cameras, radar, other onboard image processing looking for a landing site. They chose the plane of Utopia Planitia because it was pretty well known to be a pretty, an area with a lot of flat spaces, therefore relatively easy to land on. It's believed that Utopia Planitia used to be a sea at some point in the past. There's signs of an ancient shoreline at higher elevations, so this was probably underwater in the past. And this image here actually gives you a really good idea of the sort of quality of the surface here. This is also one of the sort of great images from the mission as far as I'm concerned. NASA hasn't done anything like this. They had to carry an extra camera and then set it down on the surface of the planet so that it could take a photo of the rover and the lander together. And this is great PR. This is a country that's absolutely understanding the prestige that it can gain through communication of its spaceflight capabilities. And if you thought that dropping a camera on the surface of Mars to take a photo of your rover was cool, well, they dropped a camera off in deep space so it could take a photograph of the spacecraft in flight. Japan's Hayabusa 2 mission made extensive use of deployable cameras to get scientific imagery, but these amazing images are entirely there for their PR value. After the initial reconnaissance and photo opportunities, Zhurong headed off south, and I think its main target was this black object in the distance, which is the aeroshell and the parachute attached to it. Again, this is a mission which is doing science, but part of that science is figuring out how best to land on Mars, and inspecting your hardware can provide all sorts of extra information on that front. And this stands in stark contrast to the more mature NASA program, where the engineering data which might get gained from analysing the parachute is outweighed by the fact that there's a small risk that the rover could get tangled in the parachute and lose the scientific value that the rover wants to bring from its analysis. But as of right now, Zhurong has continued moving and has just completed 1 kilometre. It's been moving about 10 metres per day. Now, the downsides of picking an easy place to land is that there's not actually much in the way of really interesting features that stand out. Again, this probably may well have been a seafloor in the past, but this is a mission that has got this ground-penetrating radar which is looking down into the surface, and we're not getting the data back from that just yet. There's a lot of analysis that has to go into that. But also, Tianwen-1 is going to move to a new orbit soon, and it'll stop being able to continually service the rover. The rover has already exceeded its planned 90 days of operation, but I expect it will continue heading southwards, possibly towards some distant peak or some other structure that is geologically interesting, and we'll see how far it gets. I'm Scott Manley. Fly safe.
Okay. It's quite impressive. And I wouldn't be surprised if they're going to compete with us one-on-one and maybe even achieve some things that we're not doing.
George, did you say when that was actually launched? When in 2021 it was launched?
It was launched in 2021. It orbited Mars for a few months, and then the lander came. So they did a kind of a two-step.
Yeah, because I don't remember even seeing very much about it. We've done a good job of not publicizing it.
Yeah. Well, I'm not
Politics.
sure. Politics, of course. Okay, let me now turn to the Parker Solar Probe. Now, this was created to basically study the sun. And so it's very made in a hardy, I guess, carbon, very thick carbon plates, because as it comes close to the sun, obviously it's going to get very hot. And so it was, how should I say, it was built in a way that will withstand the heat of the sun. However, in order to get to the sun, we used Earth and Venus to break the velocity, because unlike some of the probes that went out to the outer planets, let's say beyond Jupiter, we used Jupiter's gravity to help accelerate the probe beyond Jupiter. But in case of the sun, because it is fairly close to Earth, we actually had to slow down. And the way we slow it down is by having it go around Venus in a counterclockwise way, so that the Venus's gravity slows down the probe. But using this, they found out that they can turn the cameras on Venus and infrared cameras and really do some remarkable discoveries. Some of the things that we saw.
It's thrilling to be able to see something that's never been seen before. This emission that we're seeing is thermal emission. Even on the night side, the surface of Venus is so hot that it's glowing faintly at very red wavelengths.
These whisper images, I think, are really exciting because they provide a new window into the lower atmosphere and surface region of Venus where these extreme conditions exist. Another really interesting thing we could look for is potentially mineralogical differences. Different rocks and different minerals emit different levels of heat. We have chemical fingerprints in Venus's atmosphere and on its surface, suggesting that Venus might have been habitable in the past.
That's truly new, and I believe will yield exciting science in the long term.
Okay, so we have to wait till 2024 because the orbit is pretty elliptical. Now, Juno. Remember Juno? It was almost 10 years ago, that, well, 11 years, 2011, that was launched, and it was to study Jupiter. And so we've had some very fantastic videos and images of Jupiter. But here's one that was the latest that came from Jupiter as well as its moon, Ganymede. You can almost imagine yourself flying in a rocket ship. Okay,
Very impressive.
well, I have several other videos, but I think the next one is 37 minutes long. So I think we'll leave that for a potpourri when you need a filler. But it was an exciting year, and 2022 should be even more so. Maybe less engineering feats, but now we'll get some science out of all those mechanized robots that we have. Any
George,
questions?
Did you see anything on the China lander on the backside of the moon?
They had something like a rock that looked like a structure, but then upon closer examination, it was just a rock.
Well, that's probably the way it goes. And the other thing is, I had seen somewhere that because we did not include the Chinese in the International Space Station, they have their own now. Is that right?
Correct. And we still have an agreement with the Russia on the International Space Station, but I'm not sure if that's going to fall apart because of the war in Ukraine. But
it could fall apart physically.
Well, that's true too.
It'd be nice if it waited until we got everybody home safe.
Yeah. But
well, SpaceX has offered assistance to prevent any disasters with the space station.
Yeah. Well, we'll see what happens, but the space station is such that we really have to have cooperation, because they control some critical aspects of the station and we control other critical pieces, and you can't really shut off one without the other.
I did read something about the Chinese stuff on the back side. They tried to get some images back, but they ran into a paywall.
Correct. I tried to find, a good video of their moon probe and landing and so forth, but I really couldn't find anything that was English speaking. There were some Chinese, but I had no idea what they were talking about.
I wonder how much of the Russian space program has been financed by NASA buying trips on the Soyuz.
A lot.
Exactly.
I mean, what is it? I heard like $1 million per seat or something like that.
That sounds
something
cheap.
like that. Something like that.
That's what it costs to be a tourist, isn't it?
Yeah, but I
yeah.
think that's
3 million.
based somewhat on the cost. I mean, cost plus maybe somebody's profit in the pocket.
Yeah, it's kind of amazing.
Yeah.
All this stuff is amazing. You know, we've become so inured to science and all this other stuff. And then you sit back and you look at this and you just have to go, wow.
Yeah. It is. I mean, you know, it's like if you're in a spaceship flying around Jupiter or Venus or whatever. I mean, it's science fiction, right?
Well, you know, it makes me think of the Bible and the Tower of Babel. And here we are building it again. And the prospect that we might all just end up knocking each other off is not gone away.
So, well, you know,
Yeah, that's a whole nother 90-minute section at least.
Yeah, I watched recently the movie 2010. I don't know how many people remember, but we had.
Is that a sequel to 2001?
Correct. It's sort of a follow-on. But you know, it's a very interesting thing because cooperation with then Soviet Union was critical because, you know, part of the crew had control over one piece of the hardware and the other country had control of the other. And then there was a war that broke out or near war, like a Cuban Missile Crisis. It's you know, it was very interesting to watch because it's something that's real. So, okay. Any other questions?
Yeah, can somebody help me with the stuff on Venus? We talk about we couldn't before see into Venus because of all the cloud cover that's on it. But then the satellite went by with infrared and was able to peer down through the clouds and onto the surface. Don't we have terrestrial-based telescopes in the infrared that could do the same thing? I'm confused.
Well, I would say yes, but these are the clearest that we've gotten so far. Maybe,
certainly, they're right next door, so you get a good, nice clear picture.
It's very limited bands that come through on the Earth telescopes of the infrared, whereas you get bad broadband infrared or the flyby.
What do you mean, Larry? I don't quite understand.
Well, from Earth, there's only limited little bands that of infrared that come through. So you don't get the broad spectrum of all the infrared.
And why is that?
The atmosphere.
Oh, the other stuff just bounces around and just doesn't get here?
Yeah.
Now, you know, the Webb Telescope, they said that they could turn it on to Jupiter, and Webb is infrared. So it's possible, I haven't read about it, but it's possible that they could turn it to look at Venus in the infrared.
Is that part of the missions of the telescope, or is it primarily deep space?
Well, but I read that they can do it on Jupiter. I don't know whether they can do it on Venus.
I don't see how they could do it on Venus without looking at the sun. You know, the whole point of being at where they are is that they can't look in towards the sun.
Well, but see, Venus goes around the sun, so it's possible that there is an eclipse.
It's never going to be outside our orbit.
No, but the sun.
L2 is a million and a half kilometers outside our orbit, away from the sun.
Yeah, you might be right. But I know that he talked about doing it on Jupiter.
Jupiter, I think you could do.
Yeah.
Will be times when Jupiter happens to be.